I'm Daz, and on the bench today is a dusty cardboard box. This has been sort of sitting in the corner of my bedroom for some while, and current circumstances have reminded me of it. So let's have a look what's in this box. It's an Ultra Coronation 2. This was released in 1953 to mark the coronation of Queen Elizabeth II, and at the moment the date is May 2022, and of course we have platinum celebrations this year, so it's reminded me to get it out of the box and have a look at it. It's a battery radio, but it also is mains. As you can see, there's a socket here, and if I can release this without breaking it, you can see there's a very nice frayed mains cord in the back of the radio. There's a couple of releases here on the bottom. Just open it up, and there's a frame aerial on the back as well. And look, there's even a hole probably for a round pin 13 amp plug. Looks rather dusty in there, doesn't it? And there's plenty of very large dropper resistors, and this is an AC/DC set. I'm quite fascinated by the fact it's got Mazda valves in rather than the usual Mullard ones. There we go, model R786. Here's the battery connections here. I seem to be caught up with something there, but it's a 7.5 volt battery and an 85 volt. The filaments are connected in series. They're 50 milliamp. Obviously, if you try to drop the current for 250 milliamps, that's going to be too much. So the filaments in this set are connected in series and come to 7.5 volts. Now, it's only got 4 valves, but you've got to remember that the output pentode actually has 2 filaments in it. So that's what gives you the extra filament there. So just looking inside it, I noticed there is actually 2 detachable pins here to disconnect the frame aerial. There's a hinge here. I'm not sure if there's a way of unhinging that unless you undo these 2 screws. Also notice there's 2 chassis screws, and I also notice they are different kinds. So one looks like a sort of flat head and the other one sort of a rounded head. So I suspect someone has already been in here. It's the thing when you buy something, you just don't know what you're getting, do you? So you can see the instructions here for changing the tapping on the resistor here. 200 to 250 volts, cycles per second, 40, 100. Do they still have 40 hertz somewhere? HT is 85, LT 7.5. I'm a bit intrigued by the 75 volt, 85 volts HT. But I'm wondering is in other sets, quite often there's a dropper resistor to get the negative bias for the output pentode. So I wonder if that's why it can be an 85 volt instead of you losing 5 or 6 volts across the dropper resistor in the HT to get your bias for the output pentode. So maybe that's what it is. This unit uses a 1C2, a 1F3, a 1FD9 and a 1P11, which are the Mullard valves, and they do appear to be equivalent to your DK92 and DF91. How compatible I don't know, but that's interesting to note. So I'm going to have to try and figure out how to take the hinge off. I'm not sure yet. These look a little bit corroded. Right, I assume if I push gently, there we go, I can unclip the lid. So there we go, that's off. And I assume it's these 2 screws next. Well, I've carefully removed the knobs and the wave change selector, so I'm hoping, oh yes, something is happening. There we go. And the chassis 3. Oh good. This grill cloth appears to be plastic and it appears to have distorted with time. Whether there's anything I can do with that, I'm not sure. Something else of concern that's I've noted, and I don't know if it's because these are not original knobs or something, somebody looks like they have filed the shaft of the on-off switch, and I did note it wasn't a tight fit. That's never a good thing when you have a live chassis set. Well, that's very interesting. It's very difficult. I'm out of the focus range of my camera, but it's that tin whiskers I can see on this bracket here. How interesting. I've never seen that before, but it looks like tin whiskers. Well, I've took the chassis outside for a quick session with Mr. Brush, so we can actually see something. Some interesting things I've noticed is that there's an anti-vibration holder on the mixer valve, the looks of it, and also on the audio preamp valve, and a spring which, yes, has got some sort of connection to ground there. It's a Goodman's Industry speaker, Wembley Middlesex. A metal rectifier. I can't remember, I've not had many dealings with them, but you can see we've got our lovely Hunts across the line capacitor. I'm sure that would have a bit of a meltdown if I applied mains. That must be the audio output transformer here. This, I believe, is the loading coil for the frame aerial, because it hasn't got that many turns. There's a piece of card underneath, which I hope is just card and not anything else. I'm assuming it is. Let's have a look what we've got here. Assume that's the local oscillator coil. Some trimmers. Some more lovely Hunts capacitors. There's a trimmer at the back as well. That must be the main switch. There's an awful lot of contacts, and my goodness, they look corroded. So plenty of deoxit on that. How much have I got? Not a lot. Normal switch to break the HT in low tension, I guess. So yeah, so fairly stock, apart from seeing the anti-vibration mounts. That's obviously something you don't often see on a battery set, so I wonder if they had problems with microphony and hum pickup. I noticed some calibration marks here as well. That's the slider switch for the wave change. I think there's a slight bit of damage on the speaker. I think it's dried out and there might be a bit of rubbing there. I think I ought to put a bit of cardboard over that. The first thing I should do, so I don't end up sticking my finger through it, or the soldering iron jumps up and goes through it, like has happened in the past. Interestingly, I think this is a double cap. It looks like it's 25 volts. I think it's 50 microfarad on both poles. Yes, it's marked yellow and red, so the case is ground, isn't it? These are the filament smoothing capacitors. Of course, these being directly heated valves, you've got to be very careful about not having any ripple on the filaments, because that will just be amplified, because effectively you're ejecting it into the cathode of the valve, so the filament is the cathode. So that's another interesting thing to note. First thing I've observed is that this connection here from the changeover switch is not actually attached to the main switch, which isn't good. The next item on the agenda, I just want to have a look and see if the output transformer is good, because these are so fine. 531 ohms with reference to the trader sheet 1100. I might be able to find out what that's supposed to be, hopefully. Speech coil transformer, 510 ohms. Well, that's reasonably ballpark, isn't it? So Yep, that's good. So at least I know that the output transformer isn't open. After a little joddling of contacts and soldering this back on, we now appear to have a resistance across the low tension, so that's good news. It wouldn't be very good if I've got to turn around and replace every valve in the unit. So that's good news. I'm not going to power this up off the mains as it is for now, because obviously you've got series string filaments, and if something was to go wrong it might damage those filaments, so I just don't want to do that. I had a quick check of the IFs. They look like I've got continuity. Also on the coil for the local oscillator, I'm yet to do the loading coil. Hopefully that isn't open. So given that information I've got, hopefully it would be safe to proceed to start working on the set. I noticed the soldering on that's a little bit iffy. I've got a feeling this pot is a replacement because the wires look slightly melted where they're soldered, so I'm wondering if this is not the original pot. Certainly not tight. So just drawing out the filament string, there's a resistor right at the middle of the filament tap here. I guess that is possibly, according to the data sheet, to help reduce the current flow in the filament, because you've got anode current flowing through there as well, and I guess in the output valve that's going to be what, 9 milliamp, 10 milliamps or whatever it is. I notice there's another resistor here, another resistor here. I assume they're just all for balancing the current, taking into account the anode current that's flowing through the filament, which is of course the cathode. So basically if any of these capacitors went down while you're on battery, it would certainly destroy the filament. When it's on series string on the mains, it may not, because obviously you've got current limiting and you're dropping from 215 volts down to what, 7.5. So the fact if it was 2 volts or 7.5, there's probably not much difference in the current, but nevertheless I wouldn't trust to run it on my power pack without current limiting it, in case these capacitors went short. The other thing that intrigues me is, of course, you've got bias, because this is positive. It seems a little high, 7.5 volts for this particular valve. I think it's stated 5.5, so I'm not quite sure how that worked, whether there is anything does anything with it. Of course the IF valve is sitting at 4.5, so it must have effect with the current that's flowing through the valve. Notice that the diode triad, which is the audio amplifier, the most sensitive one, is right at the bottom, has additional smoothing. There isn't any additional smoothing for the output pentode, because I guess being a higher level valve, a little bit of ripple probably doesn't do much. I doubt you'd hear much through the little speaker in this set. So I've added a bit more of the circuitry to this drawing, just to see how the biasing works on V1 and V2, because obviously the filaments are up around 3 volts. What they've done is they've put a resistor from the low tension 7.5 to the AGC, so that the bias to these two grids is probably sitting, what, about 2.5 volts, something like that. You've got 470k, 1.5 meg and a 5.6 meg ohm. Obviously in the single parallel filament sets, these are sitting near ground, so that's not needed. So that's how they've achieved that. I looked at the COSOR 499 that I'd previously done in another video, and you've just got a division on the AGC, but on this you've got a positive bias, so that's how the biasing is done on here. Also on the COSOR, of course, there was a resistor in the negative of the high tension to obtain about 4 or 5 volts for the pentode, but of course here the filaments are sitting in this middle point at 6 volts anyway, so that's how that's done. So at least we've got an answer on that one, because that was puzzling me, as these things do. Just having a look at the power supply here. So live neutral comes in, there's an across the line RF bypass capacitor here. Then we go through the metal rectifier, and that looks like that's got a good 10 sections, so I bet that drops a little bit of voltage. I think that's 260 ohm on that section, and according to the information I've got here, it's 215 volts at this point. Then you've got the rest of the multi-section resistor, which is part of this one, and you can change your taps by removing resistance to increase the voltage. There's another resistor here, 1400 ohms, and then it goes off to the HT, so I expect it's around 90 volts there, something like that. And then you've got this dropper resistor here, which is going to the filaments, so there's going to be 25 milliamps, 50 milliamps going through that to ground for the filaments. Makes me wonder, because the capacitors that bypass the filaments are 25 volts, so if something went wrong, they'd certainly get 90 volts across them if one of the filaments went open. But plenty of smoothing, 50 microfarad both ways, just to make sure it's got a lot of the ripple out, because as I said, this is feeding the filaments, so you don't want a lot of ripple in there. While I was working this contact, the spring has completely broken, but it wasn't really working very effectively. The problem I've got at the moment is the spring lifts this slightly up and it's binding on this bit here. So, oh, as you can hear, it doesn't want to reset, so that's something I'm going to have to look at. Not quite sure what to do there to fix that problem. Just starting to do some recapping. Don't you just love it when they bury them right down there? I thought, well, I seem to be short of capacitors here. Where are they? Well, of course, when I look closely, what looks like a resistor is a capacitor. The resistor with the same colour code has got a sharp edge, and this is rounded. I've just stuck the meter on it, and it just goes to the grid of the preamp triode. And I was seeing 3 meg, so these are going to be leaky as well then, I guess. Yes, I do like the way the quality control on here with the little coloured little blobs on the various solder connections, though. That is quite interesting. I'm going to also have to look at this, because it looks like 100 picofarad, but it looks like it's another Hunt style capacitor, and I'm wondering if that's going to be leaky as well. I don't normally see ones that small, so we'll investigate that. Well, I'm progressing along. I've decided to leave the original can in and pop a couple of electrolytics underneath. Put a new earth point in. Hopefully that won't cause any ground current loops, I hope. I just got to deal with the electrolytic here. I think I'll leave that there and reroute the wires underneath, and probably get a couple of electrolytics underneath. As far as this video is concerned, what I might do is split it in two, because I noticed my videos are getting a bit long recently. The only problem with splitting videos in two is I seem to end up with about 1 million part 1s and never any part 2s, but I have started I have an account, I think I'm up to about 9 projects now that are not completed, so that's not good. Anyway, so if this is the end of the video, I'll say thanks for watching, and I'll see you for the next part.